In 2024, the on-device AI marketing for Internet of Things application generate 10.1 million US dollars in revenue. That is up about 22% from 2023. According to the According to the recent analysis, this market is projected to surge to 30.6 billion US dollar by 2029, growing at a compound annual growth rate of 25%. This growth is largely driven by what we call edge AI or on-device AI, where artificial intelligence runs directly on the IoT devices instead of relying on the cloud. So, what is on-device AI? Why it is important, and what is fueling this rapid growth? Let's break it down. First, let's define IoT, the Internet of Things. These are devices connected to the Internet. These are sensors, smart cameras, industrial machines, wearables, vehicles. They collect data. Traditionally, much of the intelligence behind these devices run in the cloud, meaning data was sent to remote servers, processed, and then results were sent back. But with on devices AI, the AI interface, the decisions making happens right on the device. This is also called edge AI. Running AI locally has several big advantages. Real time responsiveness. Since the data does not have to travel to the cloud and back, the device can react instantly, ideal for things like object detection or anomaly detection. Reduce data transfer. Less data needs to be uploaded to the cloud, which save bandwidth and low cost. Privacy and security. Sensitive data does not leave the device, improving user privacy. Resilience. If the network is unreliable, the device can still function intelligently. Now, what are the components making up this on-device AI marketing? According to the analysis, there are four main parts. Number one, AI SoC or SOM. SoC means system on chip and SOM means system on models. System on chips, these are single chips that combine CPUs, AI cores, memories, and other circuits. SOM means system on models. These are slightly larger models that include the SoCs plus memory storage and other interface for more complex devices. The second is accelerators. AI accelerators. These are the specialized chips or modules designed to speed up AI's processing inference on the devices. They do not necessarily train models, but they make running them much more efficient. AI MCU. MCU stands for microcontroller unit. These are very low power devices. Think sensors, wearable small IoT endpoints. They run similar neural networks locally. On device AI software platforms is the fourth point. This includes the software, SDK frameworks, and tools that help developers deploy AI models onto the device, optimize them, and run them efficiently. Why is the market growing so fast? According to the report, growth is being driven by multiple factors. First one is generative AI. More use cases are emerging where generative AI like image generation, language generation needs to run on edge devices. Robotics in factories or warehouse can use on-device AI to make real-time decisions without relying on clouds. Autonomous systems, self-driven or semi-automatic machines, drones, vehicles greatly benefit from having AI on the device for latency and safety. Expanded use cases, traditional use case like computer visions, object detection, anomaly detection, predictive measurements, and speech recognition are now joined by newly demands for more complex AI models. There are some use cases. Here are some concrete applications where on-device AI is essential valuable. Object detection. Security cameras or smart cameras can analyze videos on the spot and trigger alerts immediately if something unusual is detected. Second is speech recognition. Devices like smart speakers or voice assistants can run voice to text or commands recognition locally, lowering latency and increase privacy. Predictive maintenance. Industrial machines can monitor their own vibrations and temperature, run AI models to detect anomalies, or alert maintenance team before a breakdown. Dynamic resources optimization. In IoT networks, devices can adjust their power consumption. Connectivity or operations move dynamically based on local intelligence. Autonomous decision making. Drones, robots, or smart vehicles can make split second decisions based on devices AI without needing to send data to the cloud. Challenges and technical considerations. Deploying AI on device is not trivial. There are some of the key challenges. Computer constraints. IoT devices often have limited processing powers and memory, so AI models must be optimized. Energy consumption. Running AI models on low power MCUs and SoCs require balanced performance versus power usage. Model size and optimization. Developers often run techniques like model compression, quantumization, or pruning on to make models smaller enough to run on edge devices. Security. On device AI also needs to ensure that models and data are secure. There is risk if a device is compromised. Developer tools. There are need to be run strong software platform tools to deploy, monitor, and update AI models on device. There is also have been academic research in on-device AI models to address these very challenges. For example, a recent survey explored how edge intelligence models are optimized, how data processing work, and how hardware acceleration is used. Another concept is collaborative inference. There a device may share part of its computational task with other devices or with the cloud dynamically depending on latency, connectivity, and power constraints. Broader market context. To pull this in a bigger picture, the broader edge AI market is also growing rapidly. According to a 2025 analysis, edge AI devices generated 17.92 billion US dollars in 2025 and are forecasted to reach 70.81 billion US dollars by 2031 at a CAGR of 25.4%. Other reports estimated similar high growth. For example, GMI Insights projected a CAGR of 24.8% for Edge AI through. For example, GMI Insights projected a CAGR of 24.8% for Edge AI through 2034. Hardware is a major part of this growth. Specialized AI chips, neural processing units, and other processors are becoming more common in edge devices. Software and services are also growing on device AI platforms, SDKs, model optimization tools, deployment services. All of these support for the ecosystem. Why this matters? Hardware vendors they can design AI capable chips, models, or systems to tap into this 30 billion market by 2029. Enterprises and industries, companies can deploy smarter autonomous IoT devices for manufacturing, smart cities, automotive, and more. Developers, there is a growing demand for tools, frameworks, platforms to build and optimize on-device AI models. Investors, the projector growth suggested strong investment opportunity in chips marketing, AI tools providers, and edge AI startups. Governments and regulators, as AI becoming more integrated in critical infrastructure, there will be regulatory infrastructure in AI safety, data privacy, and power efficiency. Future outlook, looking ahead on device AI marketing is likely to evolve in several ways. Number one, more powerful and efficient AI accelerators. Chips will be continue to improve in terms of energy efficiency and computing power, enabling more complex AI or small devices. Number two, generative AI at the edge. As generative AI models become smaller or more efficient, we could see them running locally for tasks like image generation, voice synthesization, or creative AI on edge devices. Third one is hybrid architecture. Devices may use a mixed on device in inference or cloud-based computation, dynamically switching depending on latency, connectivity, and power. Fourth one is collaborative edge intelligence. Device work together or with the cloud. Separating tasks intelligently will become more common. Number fifth is improved development ecosystem. More optimization framework, model marketplace, and machine learning operations for edge devices will emerge. Number six is new use cases, autonomous robots, smart infrastructure, wearable health devices, or even consumer electronics will increasingly rely on on-device AI. On-device AI for IoT is the rapidly growing market, expected to reach 30.6 billion US dollars by 2029 at the 25 CAGR. This market includes specialized hardware, SoCs, accelerators, MCUs, and software platforms for on-device AI. Key benefits: real-time responsiveness, energy efficiency, cost saving, and better privacy and resilience. Use case includes object detection, speech recognition, predictive maintenance, anomaly detection, and autonomous decision making. Challenges: limited compute, power constraints, model optimization, security, and tooling. The broader edge AI market is also booming with hardware and software demands. Future trend: more efficient chips, generative AI on edge, hybrid compute, collaborative interface, powerful development tools, and new IoT AI applications. Thank you for watching this deep dive into on-device AI marketing for IoT application. If you found this useful, hit like, subscribe, and ring the bell for more tech analysis. Drop a comments, which on-device AI models do you think will be the fastest to grow? Robotics, smart home, or industrial IoT?